Video lecture was on ground to ground projectile. We would now consider a case where a projectile is fired from certain height. Let's say it's 20 meters, and then it would land on the ground. So it's fired from certain height and then it comes to ground. Now what we are asked is, what is the maximum height from the ground that the projectile would reach? And the second question is displacement when the projectile reaches the ground. We will solve these two questions, and the concepts involved are interesting. Let's first draw the path of the projectile. So let's say the projectile, and we will consider certain the velocity. The projectile is fired at an angle. Let's say that this velocity is given by 7i cap plus 10 j cap. This is in meters per second, right? That means the projectile, the horizontal component of the velocity, initial velocity of the projectile, is 7 meters per second. The vertical component of the initial velocity of the projectile is 10 meters per second, right? So let's say this is the projectile passes like this and reaches the ground somewhere here. Okay. Now let's say we are asked first question, what is the maximum height from the ground? Okay. So that means this height. Let's say, what is this height? We are asked to find out h max. Okay. Now, as we have discussed earlier, projectile is a two-dimensional. This projectile is moving horizontally and it's vertically also. There is vertical displacement. It moves up and then comes down, and it's moving horizontally. So it's a two-dimensional motion. But when we are asked the problems on this projectile, where you want to find out, let's first question, height. That means what is the vertical displacement, right? That means we want to find out the height. That means the projectile has moved up, maximum height from the ground. So anything velocity, height, to find out that, we will consider a projectile which is fired vertically upwards with the same vertical velocity, right, as that of this projectile. So we will consider, since the projectile is fired here, our imaginary projectile will be fired from the same level, and that projectile will be fired with the same vertical velocity. Vertical velocity here is 10, initial vertical velocity is 10 meters per second. So this projectile, let's say, is fired with initial velocity of 10 meters per second. This is same, okay? This is an imaginary projectile, but this is something which we will do it here, but actually this has to be done we should imagine this. We don't have to draw, but since this is an initial stage, so we are drawing this. So what will happen is, this height reached and the height reached by this projectile will be same. So this, let's say I will draw this. Let's say this is projectile will reach here, and this projectile which is fired vertically up, it will reach here and it will travel back along the same line. But to make it understand clearly, I'm just showing some distance. So this projectile will reach the ground, right? Will reach the ground. Now we want to find out this height. We want to find out this 20 is already given, right? This is 20 is given. We want to find out this height. So 20 plus that will be the maximum height. Now we can just look at this and do the thing. So here it is initial velocity is 10 meters per second. When it reaches here, what is going to be the velocity? It's because it's fired vertically. The projectile, when it is fired, as soon as it is in the air, it will experience acceleration due to gravity downwards, right? And we are assuming acceleration as 10 meters per second square. G is 10 meters per second square, and downward is negative, so it is acceleration downward. We can say it is minus 10 meters per second square. So upward velocity is 10 meters per second, acceleration is downward, the velocity will decrease, and when it reaches the maximum height, its velocity would have been 0, right? So velocity here is 0, and then it is coming down. But we would consider, because we want to find out this height, we will consider only this portion. We will say this is the initial velocity. This is the final velocity, right? And we would find out what is the time required. So time required is change in velocity upon acceleration. Final velocity is v is 0 minus initial velocity is 10. Acceleration is downward 10 meters per second square, so it is minus 10. So t is 1 second. T is 1 second. Time required for this projectile to reach the maximum height is 1 second. That means this projectile also reaches here in 1 second. Okay. Having done that, we would like to, because we want to find out this distance, right? This is the same as this. How would you find it out? We know time. We know that the acceleration throughout this travel, right, from here to here or even from here to here, acceleration is constant, right, which is minus 10 meters square. That is acceleration. So since acceleration is constant, average velocity during this travel from here to here is given by V average is given by final velocity upon initial velocity by 2. So final velocity is 0. 0 plus initial is 10 by 2. So average velocity is 5 meters per second. Average velocity is 5 meters per second. Time required is 1 second. So velocity, average velocity into time is the displacement. So this displacement is 5 into 1. That means this is 5 into 1. So this is 5 into 1. This is same as this. So this is 5 meters. 5 into 1 is 5 meters. So we have found out this H max. First answer is 20 plus 5 is 25. So H max is 25. This is your first question. Okay. Now what you need to remember, and we have discussed that, is we are not considering this projectile, the horizontal movement of this projectile at all. Instead of that, what we have done, we have considered the projectile to be vertically fired. Okay, that means it's as if we are just bringing these 2 points closer, right? And then we are drawing this. This is an imaginary projectile, but that's a important point. Okay, now let's consider the second question. You are asked now, what is the displacement when the trajectory reaches the ground? What do you mean by displacement? It's a final position minus initial position, and we can say here that the displacement is, I'll just clean this. So this is H max is 25 meters. We want to find out displacement. So we are essentially interested in finding out this, right? This is the final position of the projectile when it reaches the ground. This is the initial position. So this is the displacement, and displacement has direction, right? So this is the displacement. We want to find out that. Okay, now see, when displacement is a vector. So displacement magnitude, one is magnitude of the displacement, other is the direction. So if you want to show represent this displacement, what it means that this projectile is moving here, that means it has moved horizontally and then vertically downward. So its vertical downward displacement is 20, right? Horizontal from here, from this level to this level is yet to be found out, right? So we can say if this displacement is expressed as xi, x is to be found out, this horizontal displacement. Vertical displacement we already know, that is 20 downward. So it is xi cap minus 20 j cap. So this is what we want. So what we want to find out is x. Essentially we want to find out x. Once we find out x, that means we have given the answer. Okay. Now to find out x, the projectile is at this point and it is traveled here. So how much is this x distance? That is what we want to find out. Now to find out that, it's, first thing we would require to remember that the horizontal velocity, horizontal component of the projectile, horizontal component of the velocity of the projectile is constant. And how much is that? It is 7 meters per second. 7i, that means it's horizontal. So everywhere, here also it is 7 meters per second horizontally. Vertical here is 0. So throughout this, horizontal velocity is constant. So if you find out the time required for this projectile to move from here to here, that is the time which we want, right? It's the total time required for the projectile from moving to here to the ground. That is the time required for the projectile for the horizontal displacement also, right? So if you find out that time, then that time into 7 will be the horizontal displacement. That means x will be that time which we calculate into 7. Okay, this is what we want to find out. So first thing, we would like to find out time. How much time the projectile has taken for its travel from here to here. Okay, now again come back. Let's forget this. Look at this. This projectile which we considered with same vertical velocity is coming to the ground, right? If we find out this time, it is the same as the time required for this projectile to reach the ground. So we would like to find out the time for this projectile to reach the ground, okay? Because this projectile has same vertical velocity as that of this projectile. So what are the ways of finding it out? If you want to find out time, we would say that, let's say S is equal to ut plus half at square. We can use this because, see, this projectile, when it moves up, comes down here and then comes down. So the net displacement of this projectile is 20 downwards, right? S is displacement. Remember, S is not the distance, it's displacement. So we can say S is minus 20. Initial U is initial velocity, which is upward 10. So it is 10t plus. A is minus 10, its acceleration 10 meters per second square. 10 by 2 is 5, so it is minus 5t square. Okay, so we can get time from this. This is a quadratic equation, ax square plus bx plus c. You can find out t considering the expression minus b plus or minus under root b square minus 4ac upon 2a. You can do that, but it's slightly complicated because there is quadratic equation involved in this. Is there any other way? Yes, there is another way. What could be that way? We can find out, let's say we can find out the velocity with which this is hitting the ground. How can we find it out? We can say v square minus u square is equal to 2as. S is again this displacement. You know u, you find out velocity. Once you find out this velocity, you know initial velocity, you know final velocity, then you use the expression v is equal to u plus at. A is known, find out t, right? This is another way. This involves two steps. First, to find out velocity with which this is going to hit using v square minus u square plus v square is equal to u square plus 2as. Use that expression, find out this velocity. Once you find out this velocity, initial velocity is 10, final velocity is v, which will be negative downward. Then you use v is equal to u plus at. So you have got two steps. Here you have got quadratic equation. But there is a third intelligent way, and that's what I want to emphasize here. See, we have already found out the time required for this projectile to move here, because that is same as this, and that we have found out as 1 second. If you remember that, right? I just cleaned it up, but that time was already found as 1 second, right? This time was found out as 1 second. Should we do it again? We'll quickly do this. So actually the way we did it was initial velocity, final velocity here was 0, right? And from that we found out the time basically. So it is final velocity is 0, 0 minus 10, right? That is change in velocity upon a, that is minus 10. So that was 1 second, okay? And then from that 1 second, we found out average velocity is 10 plus 0 by 2, 5. 5 into 1, that is 5 meters. That's how we did. So we have found out the time required for the projectile to reach the maximum height, that is 1 second. Now now we want to find out the remaining time. It has reached here, from here to here. How much time is required? So how can you find it out? You can consider now, see what is the vertical velocity now? If you consider here, vertical velocity is 0. It is as if you are dropping a ball or a projectile, right? From a height of 20 plus 5, that was 25, right? We have considered 20, we have already added it up. From a height of 25, if you drop a ball, right, with just drop, that means initial vertical velocity will be what? It is 0, right? Here also it is 0. That's why we are considering it is exactly like the ball, this is the height 25. From here you are dropping a projectile, so its initial vertical velocity will be 0, right? And then it is reaching below. Now see, if you recollect from the previous videos, when you have such a situation, you are dropping a ball or any object, it reaches the ground, just dropping, initial velocity is 0, then we have a relationship that this height, that means this total displacement will be downward will be 25. So we said that 25 is equal to 5t square. Now how did we get this? It is essentially, we say that S is vertical displacement. If you drop a ball from here or drop a ball from here, vertical displacement is 25. So S is equal to ut plus half at square, right? S is ut plus half at square. U is initial velocity, which is 0. U is initial velocity with 0. So it is S is equal to, let me do this. S is equal to ut plus half at square, right? S, we can say, it's downward, you can say minus, that's fine. But if you put minus, A is also going to be minus, okay? So this minus on both, this is going to be, ut is 0, U is 0. Minus, we can say A is 10 is minus, it is minus 5t square, 10 by 2. S is 25, right? Again, that is minus because displacement is with negative sign. And hence, the negative sign has no relevance. So it is 25 is equal to 5t square. See, we are directly considering, and so this t, which we are finding out, this t will be time required from here to here, which is same as time required to move the projectile from here to here. So what is that time? T square is equal to 5 from this equation. T is equal to root 5 seconds, right? So time required for the projectile to move from here to here is root 5 seconds. Time which has already been consumed for the projectile by the projectile to reach from here to here is 1 second. So total time for the projectile to move from here to here is root 5 plus 1. This is 1 and this is root 5. That means for the entire. So total time is root 5 plus 1. Once we have found out total time, then finding out this total distance, horizontal distance, is easy. How much will be that? That will be time into horizontal velocity, which is constant. Horizontal velocity is 7 meters per second, right? So this distance, horizontal distance travel or displacement, actually I should have said displacement, total horizontal displacement by the projectile is velocity, which is constant, 7 meters per second, into time is 1 plus time root 5. So it is 1 plus root 5 seconds. So this is going to be your horizontal displacement, and that is nothing but x. X is this, right? Once you find out x, you have the expression for the displacement. Magnitude of the displacement, x, this you have to just this 20 square plus this square under root, right? Square of this added together under square root, that will give you the magnitude. So this is the answer. Thank you.